Good morning, guys. We are going to go over our homework from before spring break from Thursday. So I don't know who the sub is in here, but please pause the video and rewind it as the students need in order to check their answers or take notes or whatever. So here's number 25. They gave you vector v and you are drawing negative v. So remember, all that does is change the direction of the vector. 28, u plus 2v. Here's vector u. You put 2v, attach it to the tail of u, and then draw in your new vector right there, u plus 2v. 29, u minus v. Here's your vector u, and then attached to that, vector v going in the opposite direction as original vector v, and then the new vector that creates, this black one, is u minus v. Here's 31. They gave you the component form of u and v and asked you to find u plus v. So finding u plus v, you would just add your x components and your y components. So 2 plus 1 is 3, 1 plus 3 is 4. And then they also asked you to sketch it. So there's the sketch. Here's u minus v and 2u minus 3v. 1, negative 7. Back up here. Here's 34. U plus v is 2, 1. U minus v is negative 2 minus 1, or negative 1. And 2u minus 3v is negative 6, negative 3. At 35, u plus v is I minus 9j. This gets into a form that we haven't quite talked about yet, but you should have figured out that it's the same thing of just combining the i's and the j's. If you didn't, that's okay. We're going to talk about that more tomorrow, I think. U minus v is negative I minus 5j, and we'll talk about how that translates into a graph and coordinates later again. And then part C, negative 3i minus 8j. So if you didn't get 35, it's okay. Don't stress. And then here's 38. They gave you vector v. For v, then component form would be negative 12, 24. And then the magnitude of 4v is 12 square root 5. Okay, we're going to continue on in our notes for section 3.3. Okay, what is a unit vector? My writing thing's not working here. Hold on. Okay, here we go. All right, a unit vector is a vector with magnitude 1. So in other words, the magnitude of the vector is 1. We often will label this as vector u, for unit, of course. In many applications of vectors, it's useful to find a unit vector that has the same direction as some other given vector. So it's like, okay, you might have vector v, And what they are saying is that it is often useful if you find a vector in the exact same direction, but whose magnitude is only 1. And that is what we would call vector u. So first we need to figure out how to do that. Well, if you know vector v, how could you possibly find vector u? Well, if you have vector v, in order to find its unit vector, all you actually have to do is divide by vector v's magnitude. So if you have a given vector, say this vector's magnitude was 3, well, if you divide by 3, divide its component form by 3, you're going to end up with this vector. So that should make sense to you. Alternatively, we could write this as 1 over the magnitude of vector v, that's the vector symbol there, times vector v. So you can pull it apart if you want. That, of course, would be the same thing. Note that u is actually just a scalar multiple of v, because this number right here, that's a scalar. That's just a regular old number. It's not a vector. So it's just a scalar multiple. Okay, let's find a unit vector given this vector. So when you're saying we want a unit vector, we want it in the same direction as vector v. Well, we just said in order to find the unit vector, we have to take the original vector and divide by that vector's magnitude. So I would think the first thing we need to do here is figure out the magnitude of vector v. How do we find magnitude? Distance formula, right? So the magnitude of vector v is the square root of, but we're in component form, so they've already done the part of the subtraction. So all we need to do is take our -2 and square it, plus our 5 and square it. So that's the square root of 4 plus 25, so the square root of 29. Doesn't simplify. So therefore, our unit vector's component form is simply -2 divided by the square root of 29 and 5 divided by the square root of 29. We're not going to rationalize denominators. We're just going to leave that alone. That is your answer. Now remember, we said this is a unit vector, so technically the magnitude of our unit vector better be what? 1. How could we check that? Well, we could find the magnitude of u. The square root of -2 square root of 29 squared plus 5 square root of 29 squared. Well, squaring the numerator here, on our first one we have 4. Denominator would just be 29. The square root and the square would cancel. Plus 25 over 29. And certainly that's the square root of 29 over 29, which is the square root of 1, which is, of course, just 1. So this green work, I was just checking to make sure it really was a unit vector, meaning magnitude of 1, and it did work out that way. Okay, here's another vector. I would like you guys to, on your own, find the unit vector. So please pause the video until the class is ready, and then I will give you the answer. Okay, check it out. I got 6 over the square root of 37 and -1 over the square root of 37. So those are unit vectors. Okay, find vector w with magnitude equal to 5 and in the same direction as vector v, whose component form is -2, 3. So this time we don't want a unit vector. We want a vector whose magnitude is 5. But we do want it in the same direction as vector v. Well, take out the part of the magnitude of 5. How do we find a vector that's in the same direction as vector v? We could find a unit vector. Well, we don't need a unit vector, though. We need a vector with magnitude 5. Well, if you can find the unit vector, its magnitude would be 1, then you would just have to multiply it by 5 to get a magnitude of 5. Alternatively, what you could do is find what the magnitude of v is, and then figure out what you would need to multiply it by to get 5. But if this is some weird wonky number, it's going to be more difficult to do it that way. So I would suggest find the unit vector first, then just multiply it by 5. So what I'm saying then is that vector w is going to be 5 times vector v divided by the magnitude of vector v, because this right here would just be the unit vector that's in the same direction as v. So that's 5 times, let's find the unit vector. Well, in order to find the unit vector, we need to do our distance formula. Okay, so we've got to find that magnitude. So we've got negative 2 squared would be 4, plus 3 squared would be 9, so we've got the square root of 13. So we've got negative 2 over the square root of 13, and 3 over the square root of 13. Multiply it by 5, negative 10 over, remember how to multiply fractions, Harley. The 5 is really 5 over 1, so only on the bottom you're multiplying by 1 over the square root of 13, which is just square root of 13. 5 times 3 is 15 over the square root of 13. And that is your answer. Okay, here's one for you guys to try. Find vector w with magnitude of 6 that's in the same direction as that given vector 2, negative 4. Pause the video, try it on your own. Okay, so my unit vector, I figured out, or first of all, I found out that when I did the magnitude, I got the square root of 20. Square root of 20 simplifies to 2 radical 5. So I divided my given vector by that to end up with this as my unit vector. So this one we were able to simplify. We're still not rationalizing the denominator, but if you can simplify a radical, you should be doing that. And then we would just have to multiply that by 6. 6 times the unit vector is the same as our vector w. So 6 over radical 5 and negative 12 over radical 5. Okay, and then this is your assignment. We will finish 3-3 tomorrow and then have a quiz on Wednesday. Also, I'll be back after fourth period, so if you guys have any questions or you need anything, come see me at the end of the day. All right, do your homework.